So our objective today is to write equations from a graph. So, let's do one thing at a time. Let's take our notes, and then we can talk about homework. So we're going to write equations from a graph, and then we're going to also work on how to write an equation from, let's see, I think we'll just call it a description. Now this is in the online book, and so I'm going to give you some key pieces of information you can use if you need additional help. So this comes out of lesson 5.1, and I have a personal math trainer for the graph. Would be on page 130. And the doing it from the description is going to be on page 132. And I think there's one more. And then there's an overall one for the both of them would be on page 133 at the top of the independent practice. Okay? So if you want to go and back and get some extra help, that would be the place to go. Don't forget that your 10 marks is tomorrow is the due date. Okay, so you want to get, if you haven't gotten on, you got to get in and do your 10. Yes, question?
If we had a 0 in it, will you put in for points if we did it?
Okay, you're not going to get makeup work for the day that you were asked to do it for homework and didn't choose to log in, but what you will be getting is extra credit points for participating, and the amount of extra credit points are going to be based on two things. It's going to be based on did you do it and your score. Okay, if your score meets a certain criteria, then I can give you more extra credit points. Okay, all right. So let's talk about the first one. Let's talk about writing an equation from a graph. So let's go ahead and we'll start with a graph. Shh. Okay, so on this scale, this is going to be amount spent. So this is in dollars. And then so this value here is going to be on rentals. Okay. And basically this is a video club. So I'm going to give some parameters here. So we have a video club. And the video club has a one-time membership fee. And then it has a rental fee. Per DVD. Okay. So what we're going to do is try to figure out how to write an equation based on what our graph looks like. So I'm going to put in some points for our graph. And we're at 0.8 is 1 point. 210 is another point. 413 looks like. So it's going to be between those. It's going to be another point. At 6, we go up to 16. So I'll stop right there. Okay. So what I'm going to do, and I wouldn't normally do this, is I'd go back, I'm going to give you the ordered pairs since we are doing this in our notes and it's a little hard to see. So the first point was at 0, 8. The next point was at 2, 10. The next point was at 4, 13. I think it's 13. Hold on, let me double check. My eyes are really getting bad.
You said 13.
Yeah, 13 it looks like.
6, 6.
And then this should be 6. This one actually doesn't quite go to there. I think it's actually slightly below that. So we're going to move him. He's not going to be at that spot. He's actually slightly below that spot. So I can't honestly answer that one. So I'm actually, this one I'm not exactly sure either. It looks like that. So I'm going to give you another one that I know for sure is on a intersection. We'll do this one. How about, let's go up a little bit on our x-axis. Or y-axis, excuse me. So here's 18. And let's go 8, 18 for sure is on the graph. So that point is going to be at 8, 18. Oops. Okay. Now these numbers actually are not as accurate as I thought. They're a little harder to read, but so I'm going to take off these ordered pairs. I'd like you to do that too. So we're going to take these off and this off. Because I know for sure of this point, the 818, and I know for sure the 0.08. Okay. So what we don't have is we don't know, if I was going to make an equation, the two main things I need is a y-intercept and a slope. And I don't have a slope. They didn't tell me the slope. And that slope is that constant rate of change. So like in the Greta one, the constant with the rate of change was the 3, which was how much they paid per hour to use the rental. Thank you. So we're going to do the first thing. Anytime we're given a graph, we're going to start with figuring out slope. So slope has that formula where we're going to take the y coordinates and subtract them, and we're going to take the x coordinates and we're going to subtract them. What's important is that the ordered pair that are above each other, they belong together. They're from the coordinates from the same ordered pair. So we're going to use the 2 points that you see, the 0, 8 and the 8, 18. Okay? So it doesn't matter which point we put on top, which we put first. On top will always be the y. So 18 over 8, and then we're going to subtract, or let's put the other. We have 8 over 0. We're going to connect and subtract. So what we get is 10 over 8. And I'm going to actually change this to a decimal number, because remember what we're trying to figure out is how much each one costs. And that's going to be the piece that stays the same. That's going to be our M value. So 8 goes into 10 once with 2 left over, and 2 eighths is the same as 1/4. How would I write 1/4 as a decimal? 0.25. Okay, so we've got that. Now the next piece I need to do is to identify the y-intercept. And that's pretty easy. That one is just looking at the, no, let me do a different color. That one's just looking at the chart. So what would be the y-intercept of that graph? Okay, it would be 8. And yes, you're right, it would be 0, 8. Okay, because the x-coordinate would be 0. So what we're going to do is we're going to take those and put them together to create an equation. Okay? So remember what our equation needs to look like? Y equals mx plus b. So what would we write as our equation with a slope of 1.25 and a y-intercept of 8? What would, go ahead.
8 equals 1.25x plus
Connor? Connor wants to say it. Tell us, Connor.
I thought it was plus 5.
Okay. Okay. Remember what our equation looks like. It has two variables that are in the equation every time. What are those two equations? I mean, two variables that are going to be in my equation. We have an x and we have to have a y. Okay, so we got to keep that in mind. Okay. We're going to put numbers in for two of the letters that are in the basic form. Okay, we're going to put numbers to replace which two variables in the basic form of slope-intercept form. We got to have an x and we got to have y, so what's left over? M and b. Okay, so Samantha, write the equation.
Y equals 1.5.
Oops, not 1.5.
1.25.
Okay,
X plus 8.
plus 8. So let's go back and look at what do all those pieces mean in the equation. What does the y represent? What does the y in our equation represent? Okay, Joey?
the total cost of the video club.
The total cost of the video club, and it looks like it's going to be per month, right?
Yeah.
Okay. So total cost of the video club per month is y. The x represents, what is the x in this problem?
It's the one-time membership fee.
No.
It's the rental.
Ruby? Not the rental fee.
The rental.
It's not the rental fee. The rental fee is a number that's in that equation. What's the rental fee in the equation? Remember, you're paying per DVD. How much?
So one.
No, you're not answering my question. How much money is being spent per DVD? It's in the equation. It's in the equation. Okay? It's the $1.25. What's the X represent? Nope, that's the 125.
Membership.
Nope. That's the thing that changes, is how many DVDs do you rent per month? Okay, so we take how much it costs for one times how many we have. That's your X. What is the 8 representing? The one-time membership fee in this particular one. Okay, so how much it's going to cost me is going to be how many videos I rent at $1.25 each, plus the one-time rental fee, or the one-time membership fee of $8. Okay, that's the first thing. So let's say that you don't rent any videos a particular time. So how much is it going to cost you to have this membership? $8. You still have to pay the $8 whether you use it or not. Okay? Same with the gym membership. You can join the gym, but if you don't exercise, you still pay for joining the gym, and you have to pay every month. So it's a constant reminder, I got to get in the gym. I got to make this worth my while. I got to get in the gym. Okay? You got to be careful with memberships. If you don't use them, you end up losing a lot of money, and that's what they're hoping, is that you never show up. And they just get your money monthly. Okay? That's their whole hope. All right, let's try one where, just like the one with Greta, let's try a second one like that, so it's based on a description. So let's write this scenario out. The rent charged for space in an office. So everybody's writing this down. Building is a linear relationship. So we're going to pause for a moment and talk about that. Okay, when they say linear relationship, what are they telling you? No, not necessarily it's the same, because I don't know what it is. Linear relationship.
If one number goes up, the other number goes up?
Okay, you are going to have things increase in the same direction. That is linear. I agree with that. Okay, Justin?
Increases in a set ratio.
Okay, remember have this constant rate of change. That's linear. If I graphed it, what would it look like? Well, all lines are straight. It would be a line. The word linear has the word line in the front of it. So I'm going to get a line if I graphed it. It's going to be constantly increasing the same amount. If it didn't constantly increase, it wouldn't be a line. It would be kind of crooked things going on, okay? So that's what that means. So it's a linear relationship related to, so now they're going to tell you what they're comparing to get that linear relationship, to the size of the space rented. And I liked what Joey said. He says, when one thing increases, the other does. So if you think about it, if the size of the space you want to rent gets bigger, guess what also gets bigger? The cost for renting it, okay? And that makes sense, because they usually rent things by square foot. So the more square feet, the more money you pay, okay? And it asks us to write an equation. In slope-intercept form, and we love this form because it's so easy to graph with it. For the rent at West Main Street, office rentals. So we've got this rental company, and they're telling us that there's a relationship between how much you pay for the space versus how big the space is. So we're going to give you a couple pieces of information that go with this problem, and then we'll be able to come up, because we need two major pieces of information in order to figure out what that rate of change is. So here's your monthly rates. If you get a 600 square foot office, it would cost $750 every month, okay? If you bump that up to 900 square feet, the rental now goes up to $1,150, okay? So, number one, what is it that we are solving for? What is the Y value that we need for this problem? What is our bottom line that Y is going to represent? Remember, Y equals mx plus b. So what's our equation going to tell us?
What the rent is?
Okay. So, well, the rent is what they told us. They actually told us what the rent is. We're going to have to pick one, right?
Yeah.
Okay. But what is it that we're actually calculating? You're a business. You need an office. So what do you need to figure out? Kyler? Come on, guys. What are you trying to figure out? What is this whole problem about? Joey?
Well, you want to find out what the better deal is?
Well, no, actually this is linear, so they're all the same deal. It just dependent upon the size that you want. That's the idea behind linear, is that it's not one price for this smaller size, but it's a different price for the bigger size. Okay, it's all based on the same value, and that's part of what we're going to have to calculate. Kyler?
How much, like, each for this?
Okay, well, that's not what the Y represents in this equation, but that is one of the pieces. What's this whole problem trying to figure out? Look at the write an equation sentence. isn't it trying to figure out what you're going to be paying? The reality is they may have, you need to know as a business owner how much you're going to be paying overall for rent. And that's really what this is trying to get you to calculate, is your monthly rent. Okay. What are we trying to, what else do we need to write our equation? What else do we need to write our equation? We need two key pieces of information. We need to know slope. So how would I figure out slope? Okay, it's going to involve square feet. What else is it going to involve? Cost. So, can you guys see on these lines under monthly rates? These are actually ordered pairs.
So you can do Y2.
What we need are two ordered pairs to use the formula, right? Okay, so let's use the formula. 1150 over 900, 750 over 600. Connect them and subtract them. And it looks like we get what, 400 over 300? Which would give us 4 over 3. Guess what that value actually represents?
The unit cost.
Pardon me?
The unit cost.
Yeah, and what is the unit that we're doing? We took dollars divided by square feet. This actually represents the cost per 1 square foot. So it's approximately $1.33 that they're charging for every square foot in your business. Now, a square foot is not a very big spot. That's about a square foot. Okay, kind of like a book, this book. For that much, I'm paying $1.33. Now, you look in this room, that's a lot of $1.33s put around. Okay, so we've got that. What would the x in our equation be? What would the x in our equation be?
How many months you rent it for?
Not the number of months. It deals with the square feet. Because we want to know, well, how big is it? That's going to determine. Because they're not selling us a 600-foot or a 900-foot square foot place. What they're trying to do with those two pieces of information was to help us figure out what it costs per 1 square foot. Okay? So this is the number of square feet in the space. So here's the sad thing. We've got 3 out of the 4 pieces we need for slope-intercept form. Remember what he looks like. Y equals mx plus b. This did not tell us what the y-intercept was. That's that b value. So what we're going to have to do is figure out what it is. I need an x value. I need a y value. I need the m, because that's everything but the b. Guess what? I have all 3 of those things. Where do I get them from? Well, we just did the m over here, and I can pick one of these ordered pairs to represent the x and the y. So what I'm going to do is take the coordinates of that one ordered pair and the 4/3. I'm going to stick it into this equation, and I'm going to calculate the b. So we get the y value is the 750. We're going to get 4/3 for the m. We're going to get 600 for the x, and we're going to solve for b. Kylie, you writing this down? So 3 goes into 600 200 times. We get 750 equals 800 plus b. We're going to subtract 800 from both sides. Now I'm going to put them on top so I can do the subtraction better. and using symmetric property, I get b equals negative 50. Okay? Now I need to put it together to write my equation. In my equation is a y and an x. Always. What goes in for m?
4/3.
That's our 4/3. What goes in for b?
Negative 50.
And there's our equation. Okay? So, yes, sir.
Wait, so it's, how'd you get 800?
Because 3 goes into 600, 200 times, and 4 times 200 is 800. Okay? All righty.